Our next speaker is Joe Hilton, who currently works within the JCB electric team on implementing JCB's Road to Zero strategy, which includes growing sales of the electric products in the range. His presentation, which is Alternatives to Red Diesel, Electric Powered Equipment, will outline the alternatives which are available today.
Good afternoon, everybody. Thank you for having me. Firstly, today, as mentioned, I'm going to talk about what the alternatives to diesel are, which are currently in the market. It's going to be more focused on what can be bought today rather than future, but I'm happy to field questions on the future, most namely hydrogen, as I'm sure a lot of you have seen developments on hydrogen in the press recently. I want to start on talking why electric and why now and about the technology, and then move on to HVO, which is a here and now alternative. It's a drop-in fuel, which you can put into 95% of the JCB electric range, the diesel range today, and then onto the electric range. And then I'm happy to field any questions at the end. So why now? It's quite good timing this in terms of COP26, a climate crisis, keeping the global temperature below 1.5 degrees a year. This is where this has all started from for us and where we've started to do this from. And then you've also got the technology developments. We believe that the lithium-ion technology is at a place now where it is good enough to be able to do the job in the construction sector and to be able to last a full day's work. That would include obviously charging it within the day as well in most cases. So we believe that technology is ready and it's at a price which is affordable. And the big one is that the performance matches the diesel machine. And in some cases, we've actually seen it be better due to the instant torque on some of the machines, giving it even better. And obviously the reduced noise, and also new higher opportunities for some customers as well that we have. I know there's a lot more end users here as well, but sort of what we say is we're never going to sell an electric machine to a diesel machine. It'd be very, very difficult to sell. And then moving on to the UK climate change, which Richard touched on briefly. This is in law since 2008, which was to drop by 80% by 2050. And then in 2019, this was updated to get to net zero by 2050. And then the black line is actual UK CO2 output per year to show you just how far we've got to go in the next sort of 30 years. And it's a steep decline that we've got to hit. And our job is to make sure that I can get machines which you need at the right size, at the right price to be able to do the job which you need them to do. So firstly, I want to talk about HVO. And this is an alternative now. It's signed off on 95% of the JCB range. And HVO stands for hydrogenated vegetable oil, also known as HVO. And how is it created? It can be created from a number of different feedstocks: vegetable oils, soybeans, palm oil, and waste fats. It's normally at the minute a mix of them all. And why change is a question I get a lot. And the potential benefits of HVO are up to 10% lower NOx emissions, reduced hydrocarbons, reduced particulate matter, and reduced CO. And the reason why it's quite vague on here is it depends on which fuel supplier you use to do that. And the big thing for us is it needs to meet EN 15940, which is a grading to go into the machine. It's a drop-in fuel, so you can mix diesel and HVO in the machine. It makes no difference to service intervals as well. Now onto electric. And first I want to talk about energy demand. And obviously we've electrified, as you'll see in a minute, the low hours, low energy usage machines first, because these were the machines which we've seen as the benefits of electric suit these machines in terms of low energy, low hours, and that they'd be able to run for the full day. As you start to go up the energy demand curve, it makes electric an awful lot harder to be able to do this, because you need more power, you need bigger batteries, longer charge times. It can make things a lot more difficult. And this is why we're looking into hydrogen to look at these machines. But on the lower end, that's where we see electric, and we see it being very good. And so far, we've launched 7 products into these smaller compact machines. And that's the problem: is you go bigger, longer charge times make things harder. So what are the benefits of electric versus diesel? There's the obvious one, which is zero emissions at the point of use. There's no tailpipe emissions, mostly because it doesn't have a tailpipe any longer. You also have low noise, and this is when we developed these machines. This was something we didn't expect to be a benefit when we started developing these machines. If you take the Lodal, our compact electric Lodal, that's 10 decibels quieter, which on some of the projects that we work on can help people work longer in the day. And what we're seeing with a lot of these electric machines is they are actually working longer than their diesel counterpart because they're so quiet. Super smooth controls, and then equal performance to the diesel. In some cases, we are seeing this better due to the advantages of maximum torque from 0 RPM. Stuff like that is really helping to get that performance up that we're seeing, and in some cases it can be better. And then a full day's work, it obviously depends on cycles, and it depends on how your business used the machine. But what we've seen is we spent a lot of time looking at LiveLink, which has got over 350,000 machines on it now, and is our telematics system. And on that, we can see how long people are using machines for on average, which is really interesting, because then we can look at, we speak to some customers, they might say, I use my machine for 10 hours a day. But it might be they're using it for that, but of that time, how long are they continuously using the machine for? And on these more compact machines, it can be 2 hours or less from our data on that, which then makes it perfect for electric. And then you've got the charging capabilities as well to be able to have for it to be able to work for a full day. And then developing viable products is a big piece. The runtime, the performance, the efficiency, and the cost, we need to get it all at a level where it is doable to be able to have that happy medium for it to be right for us to make it, for the end user to hire or buy the machine. So we need to create commercially viable products, and that's what we do at JCB, or we plan to do. Then on to infrastructure, and with electric, this is the single most important part of electric machines, and having happy customers. In the UK, there's 3 known ways of charging our machines. We use the power tool systems, which you would see on construction sites today. So you have 110 industrial, 230 industrial, 230 domestic, and then we have an option for a 415 volt 3-phase fast charger as well, which can drop the charge times. And what I always say is, if a customer is expecting an 8-hour charge time and they get a 16-hour one, you've got a problem. So getting this right is pivotal for having happy customers as far as I'm concerned. And it's what infrastructure they have in place when they do it, and what can happen. It's pivotal to get this correct. Otherwise, unhappy customers isn't great for us. And then, so on the 110, if you take the 19C as an example, you would be looking at about 16 hours on 110, 8 hours on 230, and then 2.5 hours on the fast charge. And we see that fast charge for those people that are using them more, that need to get from 20 to 80% over a lunch break, have that capability. That's where we see it fitting in. Now onto our electric range of what we currently have available. So we launched our first electric lithium product was the 19C E-Tech, which is the top left mini excavator on my screen, which is a 1.9 ton excavator. And that comes as standard with what we call a 4 battery pack, which has 20 kilowatt of battery capacity, and it is fast charge compatible. Then in the last 12 months, we've launched 4 new electric products, which are the 2 in the center at the top and bottom, which are our latest products to market, which I'll come on to shortly. We also have a range of access equipment, which is lead acid powered. And we also have the Teletruck, which is a telescopic forklift. And we do two variants of that. We do a 3 ton and a 3.5 ton variant. And what I want to get across here is that the range is growing rapidly, even from 12 months ago. We only had 3 products 12 months ago, and now we have 4 new products which we brought out, which is a 1 ton electric dumper, site dumper, which is a great partner for the 19C, especially in indoor work. I know that's a bit harder with what most of you do, but it's just giving you the options that we have there, and just to show you the rate of change that we're moving at the moment. We have a compact loadal, so what we call a 52560, which is a 2.5 ton, 6 meter machine, and that will run for about 4 hours continuously, and that's got a 24 kilowatt hour battery in it. We also have a dumpster, which has got a 0.5 ton payload and a 5 kilowatt battery. And then the most recent introduction is the power pack, which is if you take a generator, which you may have on some sites, and then we thought, how would we make an electric generator? And we came up with what we call the power pack, which has got batteries in it, and they're lithium-ion batteries. And there's 2 versions. There's the 1.25 QE, which you see in the picture here, which has a 23 kilowatt hour battery, and there's the 1.5, which has a 46 kilowatt hour battery. These can also be stacked on top of each other, and they can charge all of the electric products you see on the screen. And then finally, we have in the bottom right the JCB fast charger, which is a 3-phase 415 volt, 18 kilowatt fast charger, which can charge the machines within 2.5 hours. And that is portable as well, so you can move it around sites as long as you have 3-phase. But the big thing there is you need to have 3-phase to be able to use it. And finally, on to questions. I'll hand back over to Lyle.
Thanks, Joe. That has generated a few questions in the chat, a couple which were jumped out at me initially, particularly around the HVO. I mean, soy and palm oils are mentioned as potential fuels for HVO. I mean, they themselves come under quite a bit of criticism for being used. So, I mean, are they essential, or is that something which is just it's there if we needed to use it type thing? And I'll just give a follow-on question from that, maybe deal with them. How much HVO is readily available on the market versus the industry potential demand? So if you want to deal with both of those, actually.
In terms of HVO and palm oil, I believe you can make it from other sources, but I think that puts the cost up, to my knowledge. But most at the minute have palm oil within them, is my understanding. But we leave that to the customer. It's the customer's choice to choose which HVO supplier they want to go with, and work out with their sustainability manager which one is best for them to choose for the business and from the sustainability standpoint. In terms of supply is increasing, but if everybody moved from diesel to HVO tomorrow, there would not be enough supply.
And do you see HVO being developed for general consumers as opposed to just the industrial consumers?
I think it will have a place in construction and industrial applications, but I think it will be far harder in sort of cars. Obviously, cars are going on the E5 versus E10 and doing it that way on the petrol side, whereas obviously we've tried to do a drop in fuel, which doesn't change any of the engine, and be able to reduce emissions.
Another question from the chat. According to the American Chemical Society, there's a possibility that adding more water vapor to the atmosphere by burning hydrogen could produce a negative feedback effect. Is it actually a thing, and should we be worried?
From my side on the hydrogen motor, it's still very early in the development phase of the project. We say it is zero emissions, but there are NOx, but we're having to independently verify the amount of NOx because it's that low.
Another question. Joe identified the power curve demand issues for electric-powered heavy plant, the bigger machine and the greater the power demand. Are there similar issues with hydrogen internal combustion engines and the suitability for heavy plant?
No different to what you'd have. It's an engine. It's exactly the same issue. you'd have in today, it's different power. It's a different power source. Obviously, the way it works is different, but in terms of the idea of power and the way in which it delivers the power is the same. It's an internal combustion engine. We've had JCB engines for a very long time. There's a lot of experience there, rather than working on brand new technology which is emerging and changing. This is the solution we see.
Thank you very much. Generating more food for thought, more debate, some of the challenges that we're facing in our industry in the next number of years.